Unraveling the secrets of the universe. Evaporating black hole morsels could hold the key. Imagine if the tiniest remnants of black holes, formed during the most intense cosmic collisions, could unveil the mysteries of spacetime. That's precisely what a groundbreaking study published in Nuclear Physics B suggests. These minuscule black hole morsels may evaporate shortly after their creation, offering invaluable insights into the fabric of the universe. Let's delve into the fascinating world of evaporating black holes and their potential to reveal the nature of spacetime. The study highlights that binary black hole systems, which are increasingly being studied, could serve as a reliable source of these miniature black holes. When two black holes collide, they can create smaller black holes that quickly evaporate through a process known as Hawking radiation. This radiation, named after the late physicist Stephen Hawking, is generated by quantum interactions at the event horizon of a black hole. As these tiny black holes evaporate, they emit radiation, which could shed light on the fundamental properties of spacetime. But here's where it gets controversial. Detecting these emissions is no easy feat. Small black holes are notoriously elusive, and their short lifespan poses a significant challenge for astronomers. However, the researchers propose that binary black hole systems, which can now be pinpointed using gravitational wave detectors, could provide the perfect opportunity to observe these emissions. By predicting the time and location of these collisions, astronomers can focus their efforts on detecting the Hawking radiation emitted by the evaporating black hole morsels. And this is the part most people miss. The radiation emitted as these black hole morsels vanish would be highly energetic, specifically in the form of very high energy gamma rays. These rays carry such immense energy that they can reveal the underlying structure of spacetime. Scientists have long debated whether spacetime is made up of discrete units in a foamy structure on a quantum scale. The curvature of spacetime in extreme gravitational fields and the behavior of particles at these high energies could provide answers to these fundamental questions. The quest for a grand unified theory in physics hinges on understanding the connection between quantum mechanics and relativity. Hawking radiation bridges this gap as it challenges both theories simultaneously. Relativity suggests that black holes irreversibly consume information, effectively destroying it. In contrast, quantum mechanics asserts that information can never be destroyed. The black hole information paradox arises from this discrepancy, leading to the idea that Hawking radiation encodes information about objects entering a black hole, preserving the integrity of the quantum universe. Physicists have eagerly sought after emissions of Hawking radiation, particularly from small black holes, which are the most likely sources. A predictable and abundant source of these black hole morsels would significantly advance our understanding of astrophysics. The researchers even calculated upper limits for the mass of these morsels, facilitating the transition from abstract mathematics to testable astronomical experiments. If their hypothesis proves correct, it could unlock profound insights into fundamental physics that scientists have pursued for decades. So, what do you think? Are you intrigued by the potential of evaporating black hole morsels to unravel the secrets of the universe? Share your thoughts in the comments below.